In previous lecture, we have studied multinomial distribution, which was the extension of the binomial distribution. In multinomial distribution, we have more than two possible outcomes of the random experiment. Experiment was repeated a fixed number of times, that is, the number of trials were fixed, and each successive trial was independent, and probability of success of each category remains constant in each trial. Topic of today's lecture is hypergeometric distribution. The hypergeometric distribution is a discrete distribution. Applications for the hypergeometric distribution are found in many areas with heavy use in acceptance sampling, electronic testing, and quality assurance. Obviously, in many of these fields, testing is done at the expense of the item being tested. That is, the item is destroyed and hence cannot be replaced in the sample. Thus, sampling without replacement is necessary. In binomial and multinomial distribution, the sampling was happening on the basis of with replacement. It was sampling with replacement. If you are drawing something, let's suppose if you have a bag and you are drawing a ball from it randomly, before the second trial, you will replace the ball back into the bag. But in the case of the hypergeometric distribution, you will do sampling without replacement. That is, we will not replace the item before doing the next trial. So the difference between the binomial and hypergeometric distribution is basically the sampling with and sampling with replacement. In binomial distribution, we are doing sampling with replacement, and in hypergeometric distribution, we are doing sampling without replacement. Properties of hypergeometric distribution. For each trial, there are only two possible outcomes, success and failure. This is same as the binomial distribution. Its first property was also that the experiment has two possible outcomes, success and failure. The second property is the number of trials n are fixed. This is same as in the binomial distribution, that is, the number of trials are fixed. Third property in hypergeometric distribution is the successive trials are dependent, that is, the outcome of each trial is affected by the outcome of other trials. So this is the difference between the binomial and hypergeometric distribution. As we know that in binomial distribution, we are doing sampling with replacement, and in hypergeometric distribution, we are doing sampling without replacement. So when we are doing the sampling without replacement, each time or at each trial, total number of outcomes will change because we are doing sampling without replacement. Let's say if you have a bag or a box, let's suppose this is a box, and you have two white balls and two black balls. Now, let's suppose you randomly draw a ball from it. On drawing, you noticed the color of the ball, recorded it, and again you substitute it back to the box. Ball is back into the box. So this one is with replacement sampling. But If the ball is not replaced or not be back to the box, that is, on doing the second trial of drawing a ball, let's say this is the first trial. Now you have drawn a ball from the box, and now this ball is kept at one side. Now the situation of the box is changed. Now there will be total 3 balls left in the box. Before this, there were 4 balls in the box. Let's suppose the ball you have drawn in the first trial is white ball. Now what will be the situation here? Here we have 1 white ball left in the box and 2 black ball. So now when you draw a ball from the box, its probability will be different because the total number of outcomes is affecting the probability, because the definition of the probability is number of favorable outcomes divided by the total number of outcomes. If you have here white ball, if you calculate here the probability of drawing a white ball, it would be 2 by 4. But now in this case, when you calculate the probability of drawing a white ball, it would be 1 by 3. So in this case, all successive trials are dependent. One trial is affecting the other trial. So this is the difference between the hypergeometric and binomial distribution. In binomial distribution, we are doing sampling with replacement, and in hypergeometric distribution, we are doing sampling without replacement. And because of this, the probability of success, that is P, changes from the trial to trial. In the case of binomial, the probability of success was constant. Now in this case, the probability of success does not remain constant. So probability mass function of hypergeometric distribution. In hypergeometric experiment, the probability of exactly x successes in n trials is probability of x is equal to kcx n minus k c n minus x whole divided by n c n, where x is equal to from maximum of 0 n plus k minus n to minimum of k and n. Now the question is, what is this capital N, what is this k, what is this small n? Now in this case, x represents the number of successes, same as the binomial distribution. N represents the number of trials, same as the binomial distribution. Now the new thing here is k. K represents object classified as success. You have the sample space, and the number of successes in the sample space are represented by k, where a n minus k represents objects classified as success. This is same as if you have the sample space. Let's suppose this is the sample space S, and you have total n objects in the sample space, and in the sample space you will have some successes and some failure. So successes are represented as k, small k, and the failures are represented as n minus k. So you will do trial from here. So this is the scenario that you will have total n objects in the sample space. K will represent x successes and n minus k are the number of failures. So just for the sake of summary, hypergeometric distribution applies to sampling without replacement. Trials are not independent, and peak diagram is used. A set of n objects contains k objects classified as success, n minus k objects classified as failures. A sample of size n objects is selected without replacement from the capital N objects, where k is less than equal to capital N and n is also less than equal to capital N. Let the random variable x denote the number of successes in the sample. The x is a hypergeometric random variable with this probability mass function. The binomial distribution is made up of independent trials in which the probability of success does not change, whereas in the hypergeometric distribution, x represents the number of successes among n trials. The hypergeometric distribution assumes a fixed population in which the proportion or number of successes is known. We think of the hypergeometric distribution as involving trials without replacement and the binomial distribution involving trials with replacement. The classical illustration of the difference between the hypergeometric and the binomial distribution is that of black and white balls in a urn. Assume the proportion of black ball is P. The distribution of the number of black balls selected in n trials is binomial. This is binomial, where the x is the random variable n and p are its parameters. If we put the balls back in the urn after selection, they are saying about the with replacement sampling. This is basically the with replacement sampling. Hypergeometric distribution. Here x is a random variable which follows the hypergeometric distribution, and it has three parameters n, k and capital N, where binomial has two parameters n and p if we set them aside after selection. The basic characteristics of hypergeometric distributions are: it models that the total number of successes in a size sample drawn without replacement from a finite population. It differs from the binomial only in that the population is finite and the sampling from the population is without replacement, and trials are dependent, where in the case of binomial, trials are independent.